In this question, it is given that a set A is a set of natural numbers from 1 to 14. You have to define a relation R from A to A by R is equal to the ordered pair xy such that 3x minus y is equal to 0, where x and y both belong to A. You have to write the domain, codomain and range of this relation. Let's begin the solution of this question. Now before proceeding with the problem, let us recall what we mean by domain, codomain and range. The domain of a relation is the set of all first elements of the ordered pairs in the relation R. The set of all second elements in a relation R from a set A to a set B is called the range of the relation R. And codomain is the whole set B of the relation R from set A to set B. And we also can say from here that range is the subset of the codomain. Now, the set A is given as set of natural numbers from 1 to 14. And R is given as a relation xy such that 3x minus y is equal to 0, where x comma y belong to A. So this can be written as R is equal to x comma y such that 3x is equal to y, where x, y both belong to A. So this can be further written as R is equal to x comma 3x such that x comma 3x both belong to A. Therefore, R will be equal to 1 comma 3, 2 comma 6, 3 comma 9 and 4 comma 12. As we have already seen that domain of a relation is the set of all first elements. So here domain will be equal to 1, 2, 3, 4. And range of R will be equal to the second elements. So that is 3, 6, 9, 12. And the codomain will be the whole set A, that is equal to the natural numbers from 1 to 14. So we have till 14. Hence, domain of R is equal to 1, 2, 3, 4. Codomain of R is the given set A, that is the set of natural numbers from 1 to 14, and range of R is 3, 6, 9, 12. So with this we come to the end of the solution of this question. In this question, it is given that define a relation R on the set of natural numbers N by R is equal to the ordered pair x comma y such that y is equal to x plus 5 and x is a natural number less than 4. Also, x and y both belong to the set of natural numbers. You have to depict this relationship using roster form. Then you have to write down the domain and the range. Let us see how to proceed with the solution of this question. It is given that R is a relation of ordered pair x and y such that y is equal to x plus 5 and x is a natural number less than 4. Also, x and y both belong to N. So this can be written as R is equal to x comma y such that y is equal to x plus 5 and x is equal to 1, 2 and 3, since it is given that x is a natural number which is less than 4 and x, y both belong to the set of natural numbers n. And this can be further written as r is equal to x comma, in place of y we can write x plus 5, such that x is equal to 1 comma 2 comma 3. Now in the question we are asked to write this relationship using roster form. So r can be written as, in the roster form, 1 comma 6, 2 comma 7, 3 comma 8. So this is the roster form of depicting the relation R. Next we have to write down the domain and the range of the relation. Now the domain of a relation R is the set of all the first elements of the ordered pairs in the relation R. And the set of all second elements in a relation R from a set A to a set B is called the range of the relation R. Therefore, from definition of domain, we have domain of R is equal to 1 comma 2 comma 3 and therefore from the definition of range of R would be the set of all the second elements of the relation R, that is 6 comma 7 comma 8. So we have written the given relation in roster form. Also we have found the domain of R and range of R. So with this we come to the end of the solution of this question. In this question, a set A is given as 1, 2, 3, 5 and set B is given as 4, 6, 9. You have to define a relation R from A to B by R is equal to xy such that the difference between x and y is odd and x belongs to A and y belongs to B. You have to write R in the roster form. Let us proceed with the solution of this question. Given set A as 1, 2, 3, 5 and set B as 4, 6, 9. Now R is a relation from A to B such that R is equal to the ordered pair x, y such that the difference between x and y is odd and x belongs to A and y belongs to B. So R will be equal to x, y such that the difference between x and y is odd. Also, x belongs to A and y belongs to B. This can be written as x, y such that mod of x minus y is an odd number and also x belongs to A and y belongs to B. Now in the question it is given that we have to write R in roster form. So R will be equal to 1, 4, 1, 6, 2, 9, 3, 4 and 3, 6, then 5, 4 and then 5, 6. Because mod of x minus y is an odd number where x belongs to A and y belongs to B. So this is the roster form of R. This completes the solution. This question says that the given figure shows a relationship between the sets P and Q. You have to write this relation in set builder form, in roster form, and also you have to write its domain and range. Let's begin the solution. The relation R is defined from the set P to set Q. We observe that five is equal to 3 plus 2. Then 6 is equal to 4 plus 2. And 7 is equal to 5 plus 2. So in the relation R, we can see that the first elements are 2 added to the second elements. As you can see, 5 is equal to 3 plus 2, 6 is equal to 4 plus 2, 7 is equal to 5 plus 2, where 5, 6, 7 are the first elements and 3, 4, 5 are the second elements of the ordered pairs of the relation R. So in part 1, we have to write the relation in set builder form. So this can be written as R is equal to the ordered pair x comma y such that x is equal to y plus 2. That is, the first element is equal to 2 added to the second element, where x belongs to P and y belongs to Q. In the second part of the question, we have to write this relation in roster form, where we have to list the elements. So R can be written as 5, 3, 6, 4, 7, 5. So this is the roster form of the relation R. In the next part, we have to write the domain and the range of the relation. We know that the domain of a relation R is the set of all first elements of the ordered pairs in the relation R. Therefore, domain of R will be equal to 5, 6, 7. Next, we have to write down the range. And we know that the set of all second elements in a relation R from a set A to set B is called the range of the relation R. Therefore, range of R will be equal to 3, 4, 5. So this completes the solution of this question. This question says, let the set A is equal to 1, 2, 3, 4, 6 and let R be the relation on A defined by the ordered pair A, B such that A, B both belong to A and B is exactly divisible by A. You have to write R in roster form, then you have to find the domain of R, and finally you have to find the range of R. Let us proceed with the solution of this question. It is given that the set A is equal to 1, 2, 3, 4, 6 and R is equal to A, B, the ordered pair such that A and B both belong to A and B is exactly divisible by A. That means the second element is exactly divisible by the first element. So the first part, it says that we have to write R in roster form. That means we have to list the elements of R. So R is equal to 1, 1, 1, 2, 1, 3, 1, 4, 1, 6, 2, 2, 2, 4, 2, 6, 3, 3, 3, 6, 4, 4, 6, 6. Here you can observe that the second elements are exactly divisible by the first elements. So we have listed down the elements of R, that is the ordered pairs in R. Next we have to find the domain of R, and we know that domain is the set of all the first elements of R. Therefore, domain of R will be equal to 1, 2, 3, 4, 6, which is the set A. Next we have to find the range of R. If you recall the definition of range, it is the set of all the second elements of R. So range of R will be equal to 1, 2, 3, 4, 6. This is also equal to the set A. So we have written R in roster form, then we have found the domain of R, which is equal to the set A, and range of R also is equal to the set A. So with this we come to the end of the solution of this question. In this question, we have to determine the domain and the range of the relation R defined by R is equal to x, x plus 5 such that x belongs to the set which consists of 0, 1, 2, 3, 4 and 5. Let us begin the solution of this question. So it is given that R is equal to x, x plus 5 such that x belongs to the set which consists of 0, 1, 2, 3, 4 and 5. Let us now list down the ordered pairs of R. R will be equal to, when x is equal to 0, x plus 5 will be 5. So 0, 5. Likewise we will have 1, 6, then 2, 7, 3, 8, 4, 9 and 5, 10. Now we have to determine the domain and range of this relation, and we know that domain is equal to the set of all the first elements. Therefore, domain of R will be equal to 0, 1, 2, 3, 4, 5. And as we know, range is equal to the set of all the second elements. So range of R will be equal to 5, 6, 7, 8, 9, 10. So here we have found the domain of R as well as the range of R. So this completes the solution of this question. This question says we have to write the relation R is equal to x, x cube such that x is a prime number less than 10 in roster form. Let us begin the solution of this question. It is given that the relation R is equal to x, x cube such that x is a prime number less than 10. The prime numbers which are less than 10 are 2, 3, 5 and 7. So 2, 3, 5 and 7 are the first elements of the ordered pairs of the relation R. Now we have to write this R in roster form. That means we have to list down the elements of R, that is the ordered pairs of R. So R will be equal to, for the first ordered pair, the first element will be 2. For this, the second element will be 2 cube, that is 8. Next we have 3, and 3 cube will be 27. Then for the third ordered pair, the first element will be 5, and the second element will be 5 cube, that is 125. And finally, for the fourth ordered pair, the first element will be 7, and second element will be 7 cube, which is 343. So thus we have listed down the ordered pairs of R. So R is in roster form. So this completes the solution of this question. This question says A is a set which is equal to x, y, z, and B is a set which is equal to 1, 2. You have to find the number of relations from set A to set B. Let us begin the solution of this question. It is given that set A is equal to x, y, z and set B is equal to 1, 2. So the number of elements of set A, that is n of A, will be equal to 3 and n of B will be equal to 2, that is the number of elements of the set B. We need to find out the number of relations from the set A to set B. The total number of relations that can be defined from a set A to set B is the number of possible subsets of the Cartesian product A cross B. Now, if n of A is equal to P and n of B is equal to Q, then n of A cross B is equal to P into Q, that is PQ, and the total number of relations is 2 raised to the power of PQ. Now, n of A cross B will be equal to n of A multiplied by n of B. So that is equal to 3 into 2, which is equal to 6. Therefore, the total number of subsets of A cross B is 2 raised to the power of 6, which is 64. And this figure 64 is equal to the number of relations from A to B, as we have already discussed. Hence, the number of relations from set A to set B is 64. So with this we come to the end of the solution of this question. This question says, let R be the relation on Z defined by R is equal to A, B such that A and B both belong to Z, the set of integers, and A minus B is an integer. You have to find the domain and range of R. Let us see how to proceed with the solution of this question. So it is given that R is equal to A, B such that A and B both belong to Z, the set of integers, and A minus B is an integer. As A and B are integers, A minus B is also an integer because we know that the difference of two integers is always an integer. So from this we can say that every ordered pair of integers is contained in the relation R. Therefore, R will be equal to A, B such that A and B both belong to Z, the set of integers. Now we have to find the domain and range of R. So domain is equal to, as we know, the set of first elements of the ordered pair of R. So domain of R will be equal to Z itself here, that is the set of integers. And range, as we all know, is the set of second elements of the ordered pairs of R. So range of R will be equal to, the range of R also will be equal to Z, that is the set of integers. So with this we come to the end of the solution of this question.